So we have a radioactive isotope that is going to decay. So we want to use our formula for exponential growth and decay. And that looks like our amount is going to equal the original amount, or the initial amount, a sub 0, with e to the kt, where k is our rate and t is our time. So k is our rate of decay. Now what we know now is that it has leaked into a small stream 400 days after the leak. 4% of the original amount of the substance remain. So 4%, 0.04 of the original amount, that's what a sub 0 stands for. So this means 4% of the original amount. That's going to equal the original amount, e times e to the rate times time, and we know the time is 400 days. Now we want to simplify this as much as possible, and we're going to figure out what our rate of decay is here, solve for k, and then we're going to use that to figure out what the half-life is going to be. So we're going to divide both sides by a sub 0, and we'll have 0.04 is equal to e to the 400k. Now we still need to solve for k, and it's an exponent. So what we're going to do at this point is we're going to take the natural log of each side. That way we can take our exponent and put it out front. That's one of our rules for logarithms. So natural log of 0.04 is equal to, now natural log and exponentials are inverse functions, so they undo each other. So we're left with just the 400k. Now to just solve for k, we need to divide both sides by 400. And in this problem it says round to the nearest whole number is needed, but don't round until the final answer. So we're going to leave this just like this. This is what k is equal to. 400s cancel out. So that's what our k is equal to. Natural log of 0.04 divided by 400. Now that we know that, and that's just a number, but we don't want to round it off yet, so we're going to leave it like that. What we're going to do is we're going to use our equation again, and we're going to find the half-life. So the half-life means that we're going to end up with half of our original amount. So half of our original amount is what we end up with, and we've got our is equal to our original amount, e to the kt. Now this time we know what k is. It's that big thing we just wrote down. So I'm going to try to write it tiny here as my exponent. And then I just put in t. So we essentially have what we had a while ago, except this time we're going to solve for t instead of solving for k. We have everything we need except for that. So again, we're going to divide both sides by a sub 0, and we'll have 1/2 is equal to e to this big natural log of 0.04 divided by 400 times t. And just like we did on the other, we're going to take natural log of both sides so that we can get that exponent down. And natural logs and exponential functions are inverse functions, so they undo each other. So we have natural log of 1/2 is equal to that natural log of 0.04 divided by 400 times t. Now since that is just multiplied by t, we're going to do the opposite and divide that. And I forgot to add some parentheses there. In your calculator, that's kind of important when we put this in, to have lots of parentheses so that it calculates it properly. So now we have everything that we need to put into our calculator, and we'll have solved for t. So if you put that in and then round to your nearest whole number, you should get 86 days for our half-life. Many of the problems in this section are just like this. You have to work 2 problems to get to your final answer. You'll use a similar formula for these. You'll solve for something that you don't know, like a rate or the time, and then you'll use that information again to solve for the unknown that you're actually looking for.